So American Forestry first started the program, oh golly, probably in the 1940s or so, has carried that program through up until 2021, when, for various numbers of reasons which we won't go into, they decided to hand it off, and the University of Tennessee has picked up the program. One of the guys in their natural resources department is running the program now, and so the measurement standard handbook has like 75 pages in it. So every single way that you could measure a tree or mismeasure a tree is in there. The guy and the team that came up with this, it used to be 3 pages. Well, now it's 72 or 75 pages. So he's a mathematician, but he's also a tree geek. And so he's figured out a formula for every different way to measure a tree. And it can be rather overwhelming with the math and the calculus and the trigonometry and the algebra and all that stuff. Well, he's made up Excel spreadsheets to where you only have to plug in the number and it'll give you the thing without having to go into mathematics, you might say. But so anyway, we can compare this cottonwood with the cottonwood in Massachusetts or in California or wherever. And so the national list just takes the first place, the largest first place tree. There are some that are tied for first place, and they do the way they work that is taking the national points of the tree. If one is within 3% of the other one, then it's considered tied. So here in Colorado, we've kind of blown that out of proportion, and but we take generally the 3 largest of any one particular species to give more cities and so forth a little more bragging rights, as it were. And but as a, for instance, with red oaks, we have 6, maybe 7 red oaks that are tied for first place. So some of them are here, a lot of them are here in Denver, one in Fort Collins. I'm trying to think of where else. But anyway, there's somewhere in the neighborhood of maybe 820 trees on the list. So we spread the wealth out as best we can anyway. So we take a quarter of the points on the crown spread. So we add the circumference in inches, or the circumference in inches, the height, and then a quarter of the crown spread to get the total, the national point value. Using that national points, we can compare trees across the country if people are all doing it the same, and hopefully they are. Typically, let's measure the trunk first, and I might need some help. So, DBH 4.5 feet above the ground. This rope just happens to be that, or on me, it's about right here. So, you know, hold that just on the ground. So, about this crack right here. Okay, that's good. You know how to go. So, obviously using a DBH tape, you're going to go ahead and go around. Try and make as level as you can. Most trees have a fairly round circumference, but some of them are a little oblong. I don't think it makes a whole lot of difference how we measure that, but they should come pretty close. What do we got here? 89.3. So, good sized tree.
68.
68, I'm sorry. Yeah, 68. I'm saying big job, right? So, well, I hope so. Yeah. So, what, 5 feet, 8 inches in diameter or so? So, obviously, yeah. So, in figuring national points, the size of the trunk is actually figured in circumference, not diameter. So on the Champ tree list that I have, I've put in formulas that just, when I put in the diameter, it'll figure the circumference and then click on to the height and so forth. So let's jump back to the trunk measurement. Obviously, if this is on pretty level ground, most places in the Front Range are going to be fairly level. But in the mountains especially, or the foothills, you're going to run into situations where it's on a hill or on a slope. So if you've got a slope like this, the trees like this, the standard is to go mid-range, the middle of the trunk, and then go 4.5 feet or DBH up from that. So I suppose you could go on the low side and then on the high side and average it, but the standards on measurement is to go mid-trunk. On this one, obviously, somewhere around here, and then take your measurement from that particular spot. All right. So again, most of the time it's pretty simple, but occasionally you'll get a little difference, and so that's how that's taken care of. If you look behind you, you can see this pine tree. There's a little bit different way on this guy. If at 4.5 feet or DBH, you have a branch attachment, a burl, a wound of some sort or another that sticks out from the trunk that will throw your measurement off. Then we go to the narrowest point on the trunk, and DBH is about right here. And compared to here, this is going to be quite a bit bigger measurement. So we go to the narrowest point, and just to show you the difference. $35.6. And I would probably go about here or so.
Hand it around to you, Neal.
Yeah, thanks.
Good way.
$32.3. So a little bit of a difference, but it's a more proper, more fair way to measure a tree. If those branch attachments are pretty close to the ground, like some of our trees are, let's say this guy is right here. If there's enough space at the narrowest point, you might measure it this far off the ground. That's still legal, if you want to call it that. It's still okay to do that. Again, so we want to try and be fair in our measurements from one point on the trunk to another. As opposed to 5 trees planted together that kind of grew out. It's a pretty weird example, but sometimes they'll come out all from the same point and sometimes be spread out like this. So technically, to measure the DBH on this guy, I'd probably go about mid-trunk and measure up 4.5 feet, and then take this measurement on this angle that's perpendicular to the lean of this particular trunk. So we just got done measuring this guy. We'll go back. So to determine whether it's a multi-stem tree, which obviously this guy is, but determine the multi-stem characteristics of it. If let's say that we just had these 2 trunks, okay? You take an imaginary line, pith line, or the center of that particular stem, and you look at the other one as well. If those imaginary lines intersect above ground, we can call that a single stem tree, even though it may look a little funky. If they do not intersect, then we would classify it as a multi-stem tree, use a little different measurement procedure. Sometimes you will find a lot of cottonwoods and willows particularly are multi-stem, as you've certainly experienced. So they can be a little tricky because I've seen some trees which on this side, that could, let's say for instance, that this looks like the 2 pith lines intersect above ground. You go to the other side of the tree and they don't. Well, what do you do then? Well, average them. So one side of the tree can be different from another side, but obviously none of these pith lines intersect, so it's definitely a multi-stem tree. So we'll, as a for instance, measure this, the same way. On this one, again, we want to measure up with the lean of the trunk, and then perpendicular. Anybody want to guess this measurement?
16, 17.
Huh?
18.
17.
12.
12.8.
I got 15.1. Pretty good. Pretty good. So, however many stems, in this case there's 4 or 5 stems, we take the diameter measurement and square it. So 16 times 16 is 256, right? Okay, say yes. Okay. So 12 times 12, 144. So whatever measurement you got, 12.2, you square that. You add all those numbers up. So you square all five trunks, add that to get a total, and then you take the square root of that total point value to get your actual trunk measurement. And why we do that is to kind of more precisely or more equally compare one tree to another. Every multi-stem tree, virtually every multi-stem tree, its base, if these were connected, and if we could get a tape measure around all of those, is going to be much larger than a single stem tree. Okay, so by doing this particular method, this particular formula called functional circumference, you could also use functional diameter, obviously, then it always reduces the size of the measurement of a multi-stem tree to more closely compare it, or more fairly compare it to a single stem tree. So, any questions, comments on that? Does that make sense, kind of?
So if you did the math on that, and if you measured all of those trunks and you squared each of those values and added them and took the square root, this tree's diameter comes out to be 36.08.
Yeah, 36.08. And just looking here, you've probably got easily, 48, maybe as much as 64 inch DBH if you can measure it that way. So it always reduces it by a fair amount, depending on the difference. But that's how we try and measure a multi-stem tree to, again, more fairly compare it to a single stem tree of the same species. It doesn't matter which way you do this, obviously, but I've got a 100-foot tape, and so typically I'll go north to south and east to west and average the two. So again, if I could get some out. All right, so let's go that way. And as you would drop a plumb bob line or whatever to get the full width of the canopy, if it's in between feet, just round it up. I mean, it's a point per foot. So again, if you're a point either side of that, or a couple points either side of that, that's fine. I got 72. So if you go that way. And we'll make it 50. So you can add them together and divide by 2, or subtract the difference and divide it by 2. 22, so add 11 to 50, and 61 feet would be the average crown spread. With some trees, they can be really lopsided, and you'll have, like this one where it's 20-foot difference, and that's fairly common. Some will be within 2 or 3 feet from one measurement to the other. If we were measuring this tree and we thought it might be a national champion, there's a little more complicated, a little more time-consuming way to measure it. Typically, they'll take each branch from the trunk and maybe do 10 branches around the full circumference of the tree to get a better average, if you want to call it that. So, but generally with most trees, doing one direction, going 90 degrees to that is usually plenty enough to get you close enough and so forth. Down through the years, technology has obviously changed quite a bit. Anybody familiar with a clinometer? Yes? Okay. Well, that's what we used to use, and it was, you know, pretty accurate for the most part. But then when laser rangefinders came out, this particular model, this Pulse 200, I think is good within 6 inches or so. And so in measuring the height of the tree, obviously the taller the tree, the further out you're going to have to go to do your measurements. On average, probably a tree that's up to maybe, let's say 30 feet tall, going out 50 feet or so is probably about right. But on a tree like this, we want to go out far enough to see, like that tree in the background. Take a look at that one. You can probably tell fairly well what's the highest point in that tree, but you want to get out far enough so we can see all the branches across the top of the tree. So if we're, you know, obviously right here, we're still under the canopy of the tree, so we've got to go out quite a ways to be able to do that. Typically, I'll probably go at least 100 feet on this guy or more, and so taking shots across the top of the canopy of the tree, on a tree like this, these bigger trees, I might do maybe 10 or maybe as many as 15 shots in the tree, because oftentimes if you've got a gap opening in the canopy and you've got a branch like behind it, oftentimes that branch is actually the tallest. So what looks the highest to you may or may not be the highest point in the tree. So that's why we take as many shots as we can do to make sure that we've hit the highest point in the tree. With most laser rangefinders, their manuals will only give, well, one or maybe two different ways to measure the height of a tree. It's the difference between the tangent and the sine method. We won't get into trigonometry, but the 2-point method, shooting the top of the tree and then shooting the base of the tree, has found to be the most accurate way of measuring the height of a tree. And so obviously you'll get a measurement in feet or yards, however you set it, and then it'll stay inside the screen for a number of seconds, and then shoot the base of the tree. Most of the time, because my height is here or your height is here, you've got to compensate for that 5 or 6 feet above ground that you're taking the height. So most of the time, when you shoot the base, it's going to be a minus number. So you need to add that to your height measurement on top. If it's a plus, where the base of the tree is up here, then you have to subtract that from your measurement on top of the tree. How many of you guys, folks, have used this? Okay, so good amount. Most of the laser rangefinders work similarly, but I just have to get this true pulse, and so it seems to work pretty well. Let's take a look. If a number of you haven't done this, come on with me and we'll take some shots. You have to, when you're measuring the height of a tree, you have to see both, from your vantage point, both the top of the tree and the trunk, or get within a range to where if you've got some foliage in front of the trunk, to where you can guess that it's going to be this height or another. So, all right. So we're probably far enough away, and this one probably not too hard to tell which is the highest point in the tree, but sometimes Sometimes it'll surprise you. So we've got essentially 3 big leads. Between the center one and the right one, there's a little bit of a gap. Like I said, sometimes the highest point is that branch behind it. So the beauty of the 2-point method and of this particular unit is that wherever you shoot a point in the top of the tree, it drops a right angle. So as we talked about the 3-point method, the tangent method, that assumes that the highest point of the tree is right over the center of the trunk. Well, most deciduous trees it's not. And so if you're assuming that and you're shooting maybe 10, 15 feet off from the trunk, your angle's going to be off and your measurement's going to be off. But so if you do the 2-point method, you're assured that wherever in the canopy that you're measuring the highest point in the tree. So with this particular model, these buttons on the side will give you horizontal distance, vertical distance, inclination, lots of different other measurements. So it's important to be on the VD, vertical distance mode, okay? And take a couple of measurements. 4, 74 and a half, 72, 74, 74, 72, 71, 71, 68, and I'm positive 1 foot, so get about 73 feet tall or so. So, anybody want to jump in here and try it?
Try it?
Sure. Okay.
How you do it?
You just push this button on your pointing on the tops of the branches of the trees. Hold that for you if you want. Yeah. So you just push it, and if you don't get a reading, you're shooting in the air. So.
75.
Okay. So keep that in mind. So keep moving to different parts of the tree. So we got 75 and a half. 71, 72,
5 again.
okay, so you're pretty confident you got 75 at ground level.
Okay, it's 1.
This one. So that's
74.
plus 1, so it'd be 74 feet tall. So it's really a very neat instrument. Sometimes where I'm not sure, where you have a lot of competing foliage and with bigger trees, go on the opposite side of the tree and shoot that. If you're shooting directly into the sun, the laser cancels out. So you'll say laser in your screen, and so you have to find a place where you're not directly looking into the sun. Anybody else want to give it a try?
The top of the tree to be at the top of the stick.
Correct.
Okay, so maybe that's why we have editing. So maybe. So the internal markings here. So if we use our Biltmore stick, and I'm 100 feet away, looking at the top of the tree, the Biltmore stick is saying it's 65 feet high, so
0.5, 60?
60, so maybe this isn't so bad.
Maybe not.
So
you're reading that up the side here?
So the middle, I think, is where,
Okay.
so 60,
Okay, I see what you're doing.
yeah, so 65, yeah. Yeah, 60, yeah, it's right in that 65 mark, so
Only 5 feet off, which
yeah,
isn't bad for a stick.
not bad at all for a stick.
How about that?
So,
Huh.
all right, so
I'm semi-surprised.
So there you have it, folks. You can measure fairly accurately with a stick if you don't have $1,200 to shell out.
for these range
for one of
finders.
these range finders.
Yes.
So here we are measuring this elm tree. Not a champion, but it's a big tree. So
Okay, on the left scale is degrees,
mhm.
and the right hand scale is percentage.
Okay.
I don't know, can't remember exactly what that is, but
Okay.
the degrees in a formula will give you the height as well as a percentage. So,
Okay.
anyway. You kind of got to use your left eye to, well, whichever eye you're doing, the other eye to see where the horizontal line, marker, whatever, is when you're shooting the top of the tree. So at the top of this one, which I'm kind of thinking straight ahead,
Yes.
is probably the tallest. We'll see for sure.
Yeah.
But that one, that very tippy top on the right hand side of that is 70, we'll call it 70% and 45 degrees.
Okay.
Alright.
All right, Neil. Now we're
Okay.
going to check it with the rangefinder. So 45 degrees.
And 70%.
And 70%. Okay.
So I can do let me do the inclination on here. So according to this, it's 33.4 degrees. And then if you were to shoot the horizontal distance,
Mhm.
then in your using geometry, your what is it, a squared equals b squared plus c squared.
Mhm.
Flip the formula around,
Right.
and it'll give you the height. That's not the hypotenuse. Hypotenuse is think is a horizontal line. I forget.
Yes. So that is like the Pythagorean theorem.
Yeah.
I think is what you're
I think
referring to.
So with the rangefinder, you got to go over to VD for vertical distance, not
Vertical.
HT. Height, it's VD.
BD.
And so we'll have to do a couple readings here. 67, 66, 68, 67, 62. Ooh, 73 on the right hand side.
Oh, okay.
See? We thought. See, that's where your clinometer is going to be off. 74. Okay, so I got 74, which is the highest point
On that right
of the
limb.
right hand side, sticking up by itself.
Gotcha.
Okay.
Okay.
So then shooting the base of the tree. That's 8 minus 8, so you have to add that to 74, which is 82 feet.
So an 82-foot tree with a clinometer 45 degrees.
Well, since we now know the highest
Yeah.
point of the tree, you want to use a clinometer again?
Sure.
Okay. Turn that gun off. Okay.
We're arborists. We can do math and stuff.
Yeah, sure.
Just give us a spreadsheet.
Yeah.
So the inclination on that.
It's less.
All right, you heard it here, folks. Use a stick before you use the clinometer.
So we got 30 degrees and 62%.
Do you have to account for your height? I think you have to add it.
Probably.
So
So if you use 62 plus 6, which is my eye height,
68,
and that's 68.
and we got
We had
70
70 before, 70%.
70%.
So that's pretty close.
Okay. So
That is.
it's less accurate than the stick. So use a stick if you don't have a rangefinder.
Really?
If you have a clinometer, check it with your stick.
Yes. Anything else?
How about you talk about the importance of taking pictures of the champion tree, Neal?
Yes. We on Co-Tree View, besides the statistics of the size of the tree, there is a section that you can add the picture of that particular tree. Oh, and one other measurement I forgot to talk about that I take is the GPS coordinates of the tree. In town, you'd usually have an address. Sometimes in a park, it's a little bit harder to find if you've got a big park. So whenever I'm measuring or remeasuring a tree, especially with some of the trees in the mountains and the foothills, honestly, the first person who discovered it said something to the effect of, you take this highway to this Forest Service road and go about 2 miles, and then you go about this, and it's down the hill about 200 feet. Pretty sketchy directions. So any kind of out of the way tree, I try and get as precise a measurement as I can as far as feet from a landmark that I think is going to be there for a while, so that if somebody else has to drive 3 hours to find this tree, they'll be able to find it and not be disappointed. So we try and do GPS. The app that I use is called Polaris, but there are other hiking and climbing and apps on the on the web. Polaris is a free service, so don't have to pay for the thing. Gaia is another one, GIA, something like that. That one you might have to pay for, but the beauty of this particular app is it not only gives you the GPS, gives you the elevation, the direction, lots of other. There's a clock on it, lots of other things. So it's a pretty neat app, but it's really helpful, obviously, even in town, to where if you punch in the GPS coordinates of that tree, you're going to find it somehow or another. So that's the beauty of having GPS coordinates as opposed to topographic coordinates, where you might get to a quarter of a quarter of a quarter section. Well, that's still a pretty good area, especially in a forest. That could be, that could be a couple hundred acres maybe, or maybe not quite that much, but it's still a big area. And if you're dealing with a place that you've got potentially 200 or 300, 400 trees, and one of those is the champion. So that's why we try and get as detailed directions to the tree as we possibly can. And the pictures are also helpful because we can download those as well.
You want to tell the story about our potential champion, national champion mahogany, curl leaf mahogany, Neal?
Oh yeah. Well, I dragged my wife around to look at some of these trees, and she's pretty good about it. But we were taking a trip up to Vernal, Utah, and Dinosaur National Monument. And if you ever have a chance to go up there, the Utah side is the one where it has the hillside and the bones sticking out of it. But Colorado has a Dinosaur National Monument as well. So we drove up there, and just the scenery is, most of you know what Utah looks like, red sandstone all over the place, and just awesome canyons and rivers and so forth. Well, we decided to look at some of these canyons, and about 30 miles north of the visitor center off the highway, we decided to take one of the side roads off to an overlook. And so we went about a quarter mile or so and pulled up in the parking lot. And off to the right hand side of the parking lot, these smaller trees looked like it had snowed, just almost solid white. I said, what the heck? You know, this is just weird. Well, so I had to go over and find out, right? And as it turns out, these are curl leaf mountain mahogany that, if you're familiar with that plant, a native, mostly a shrub, you might get some stems maybe 2 or 3 inches in diameter, or usually they're a multi-stem plant. Well, I was shocked to find out that there was a small group of these trees that had diameters from 8 inches to maybe 12 or 13 inches, a real single stem mountain mahogany. So unfortunately, I didn't know that that was on the national champion list. And so typically when you nominate a national champion, they want to have you take pictures from all 4 directions, a picture with your tape measure on the trunk, and maybe a whole tree shot, at least some of those, so that when you turn it in, or if you shoot it over to me, I turn it in, whatever, that they can be assured that you measured it properly and ID'd it and so forth. And so I measured the tree and I took 1 picture. So if any of you were going that direction, it was quite a trip, but beautiful scenery up there. But we really can't nominate it until we get all the information, especially the pictures. So
Just take lots of pictures.
but that was a fun adventure for sure.